This video lecture is going to be on normalization in a database. Now, what is normalization in a database? The first thing to understand when you're doing anything and you're creating a program for your users, keep in mind the fact that if a user can make a mistake, a user will make that mistake. So a good design tries to remove the possibilities of as many mistakes as possible. And this is the heart of normalization. Normalization means we're going to go through and look at a database and we're going to try to normalize, or in essence standardize, exactly how the data is going to be stored in our database. Now, what does this mean? Let's take a look. The idea here, the process of normalization, is we're going to be converting an unnormalized table into two or more tables. We're going to be changing this then from a poorly structured to a well-structured database. And again, the idea here is to make these better functioning and to remove the possibility of having errors in your data. So looking at this, what is this? This is the data integrity problem. How good is your data? Is there errors in it? Because if there's errors in your data, then your data is going to be less useful. So what kind of data integrity problems are we talking about? We're looking at the idea of different names for the same entity. So the concept of being able to enter in, as the user's putting in information, can they put it in wrong? Let's say, for example, a field is going to have only 5 or 10 or 15 of the exact same entries repeated over and over again. A good example of this is if we're storing the type of weight, and we're talking grams or kilos. When we're looking at this, making the user type in the word grams over and over again, you've got the possibility of an error. One time the user might type in GRAM, and the next time they'll type in GRAMS, and then one time they may misspell it and call it GRMS. And to the computer, because remember, the computer doesn't know the difference. To the computer, these are 3 different entries. And I know you're sitting there thinking, well, how come the computer doesn't understand exactly what it is? And that's because the computer really doesn't know anything but ons and offs. So looking at this, the user then has entered 3 different values for the weight. And so if you go to do a search or to do any information on that data, it's not going to find every instance of where you want grams because of this. This is going to then produce incorrect and inconsistent data information. Give me all the weights in grams, and you type in GRAMS. Well, the computer is not going to be able to differentiate and will only pick up the ones that are entered in that way. So to normalize, we're going to resolve this by eliminating the possibility of these errors in duplication. We're going to do this by normalizing tables. We're going to eliminate data duplication. Now again, this is a little slower to process because as soon as you add any type of overhead into a database, it's going to slow it down. It's going to make it larger. But the trade-off between being slower and being accurate is more than worth it. The idea here now is again that every table has what we call a single topic. And let's see this. Let's see an example of this, see if this helps. Let's talk book collection. Now, anybody who knows me knows one of my greatest weaknesses is books. I love books. I love the feel of books, the smell of books, and being very old school, I still do an awful lot in analog. I have actual books, and I enjoy reading the books. I like this better than the digital version. I have actually so many books, I have a storage shed. There's no more space in my home to store them. I actually store them in a storage shed. That's how many books I have. And yes, I've reread maybe about half of those books, and some of them more than once. But the thing is that I have this large collection. Now what happens? I walk into a bookstore, or I go into a used bookstore, and I start looking at books, and I see one that I like. And I'm looking at this, and all of a sudden I'm saying to myself, all right, do I already own this book? Because nothing's more frustrating than getting a book, getting excited, and you purchase it and bring it home, and you go and you notice, oh my gosh, this is my 2nd or 3rd or 4th copy of this book. So what am I going to do? I'm going to build an app for my phone. I'm going to have an app where I'm going to enter in every book I own. And in this way, next time I'm presented with this difficulty and I'm in a bookstore, I'm going to be able to pull up that app and say, oh, look at this book. Do I already own it? And because, as we know, behind every application, behind every app on your phone, there's a database. So I'm going to have to build the database that stores this data. How am I going to build this database? Am I going to open up Access right away and just start entering tables? No, of course not. Because as we've learned in this course, you do the heavy lifting first. You design it, you build the blueprint, and you validate that blueprint long before you ever open a database and start creating the database itself. So what I will do is I'm going to go and open up DIA, and I'm going to start designing this database. I'm going to start saying, okay, what's the purpose of this, and what am I going to store? Well, the purpose of this is going to be to store the data on my books. And what am I going to be storing? I'm going to be storing this type of data. So what data is stored? I'm going to obviously need to store the title and the author of each book. And so what I will do is I'm going to put down, I will store the title of the book. I will store the author. I've got the author's name. And then I'm going to add extra information in there. What I'm going to add is going to add the publisher of the book. So just in case there are different versions of this book put up by different publishers, sometimes there's variations in the books, and this is something worth having. So it's worth noting whether and who the publisher was of each book. And then what I'm going to do is put the genre of the book. Is the genre, because as everyone knows, my favorite books are either romantic novels or romantic historic novels or nonfiction. So I'm going to sit there and have the genre. Is this a romantic historic novel? Is this science fiction? Is this a history? Is this going to be a war story? What type of genre is this book? So I'm going to put all of this down. This way, when I do a search, I can say, give me all of the books that are historical romances that I have. Now, to do this, I'm going to need, obviously, a unique ID. I'm going to need a primary key. And as we know, this must be guaranteed to be absolutely unique. Well, books already have this. There is the ISBN number on every book, or ISB number on every book given by the Library of Congress, which uniquely identifies each and every book. So I already have a built-in primary key that is provided to me on the inside of every book. So this is what I'm going to store. Now, looking at this, I'm going to now validate. What's the purpose of this? I want to be able to retrieve the list of books I already own in order to check and make sure that I don't have it. Does this accomplish that task? Yes, it does. Now I'm going to normalize it. By validating this, one of the steps of validating is I'm going to normalize this data. What does that mean? Looking at this, is there something that is going to be repeated in a finite way that's not going to be different every time, that's going to be repeated a number of times, though, that I might type in wrong? And right away you can see a lot of these are going to lend themselves to that problem. The genre, for example, if I'm going to store this and say I'm going to store science fiction, well, one time I might store that as sci-fi, and I'm going to put down in this book as a sci-fi. Next time I'm going and I'm entering a book, I forgot I did this, and I'll just put down that it's SF. This is a science fiction book. And then next time down I'm going to put in that this is a science fiction. Do you see the problem? This repeats itself. The genre of science fiction is being repeated, but I might enter this differently in there. And even if I agree to myself that I'm going to put it in as science fiction, what if I spell it wrong? What if I forget to put the space in between there? Again, to the computer, these will be different entries, and my data then does not have integrity. So right away I can see this needs to be normalized. What I'm going to do is I'm going to normalize that field, so I'm going to remove the possibility of having a wrong entry. Looking at the publisher, same thing here. Simon & Schuster is one of the publishers of books. Well, one time I might put down Simon & Schuster and I'll use the little ampersand. The next time I'll forget and I'll put the word in and. On and on. And you can see what the test is, I'm looking at each field and I'm saying, does the data repeat itself? And then does it lend itself for the probability of an error? So again, publisher matches that. Looking at author, same thing now. One of my favorite authors is Arthur Charles Clarke. Arthur C. Clarke wrote Childhood's End, 2001, A Space Odyssey. He wrote a number of books. Now I'm going to enter his name in here. Well, one time I put it down as Arthur Charles Clarke. The next time is Arthur C. Clarke. I may just put down Arthur Clarke one time and A.C. Clarke the next. You see again now, I'm going and I'm asking, looking at this, I'm using common sense to say, is there the probability of putting in an error, putting it in wrong? And again, this lends itself to that. I move on to title. I'm looking at title, and now I ask myself the same question. Is there the possibility of having that in there? And so what I want to do is normalize that. For example, the title of Outlander. I have 4 different books with the title of Outlander. I've got the Gabaldon book, obviously, of Outlander. I also have the science fiction book by Alan Dean Foster named Outlander. I've got the movie book, the book based on the movie that was Sean Connery, also called Outlander. So looking at this, here is something that's going to repeat itself, but does this lend itself to normalization? And here again is where common sense has to come into play. No, the idea that even though there's the rare case where a title is going to repeat itself, here I'm going to want each instance to be in there on its own. And what I will do then is the risk of putting in the duplicate title erroneously is worth not normalizing it. This data needs to be entered in as is. So this does not get normalized. Even though you can come up with a 1 or 2, and again, they're very rare examples of where it might be duplicated, whereas here, it is not very rare. Here we're going to have a finite number of the same entries put in there. And this is the difference. And again, hard when you're first learning this, because the idea here in the concept is being able to apply what you're going to use this for in the end. Finally, looking at ISBN, should this be normalized? And there a resounding no comes out. Because it is going to be unique, it must, by the definition of a primary key, be unique. You would never normalize that. So now what we've done is we've identified, and what I want to do is I want to normalize this database by normalizing these 3 fields. And as we said before, what that means is breaking this out into a separate table and then having a relationship between this new table. So looking at this again, the ambiguity, let's start with author. Again, too many chances for bad data, and I'm using my example here of Arthur Charles Clarke. And looking at this again, the number of different ways to be able to put in an author, and therefore the ways of having erroneous data. The computer would look at this, and again, keep in mind, the computer does not know that I meant the same author there. All it knows is what was entered, and to the computer, these are 2 different entries. That's why this should be normalized. So normalizing, break down what are duplicate entries. Looking at that then with the author, and I've got publisher, and I've decided genre are all going to be normalized because these have the high probability of erroneous entries. To do that, all I simply do is I create a new table, a new entity for genre. What is it going to contain? The genre type. Is this science fiction? Is this historic romantic? Is this going to be a nonfiction? What is the genre? And then I will give that a unique ID. And here, looking at this, I could either use auto number for this or come up with my own. It doesn't matter at this point. What matters at this point is I'm going to identify the unique identifier, the primary key. I am then going to have here, this is the primary key. I'm going to create a relationship to my book data table or entity. And there what I'm going to do is my foreign key will go there. How did I know my foreign key went there? because this was a one-to-many relationship. And in a one-to-many relationship, the foreign key always goes on the one side. And again, knowing how to read this, a book has one and one genre only. A genre must be associated with one or more, with many books. Therefore, this is the one side, and the one side always is going to turn around, and there is where the foreign key goes. By reading this, a book has one and one only genre. This is the one side of that relationship. The foreign key goes there. I do the same thing with publisher. I've got a new entity here. It's going to come with two attributes. One will be the publisher's name. So one will be DK, one will be Simon & Schuster, another will be Random House, whatever then the publisher is, and I will assign a unique ID to that as the primary key. Again, I have a relationship with here, the relationship, a book must have one and one only publisher. So looking at this, which is the one side? A publisher must be associated with many books. So publisher with many, that's the many side. A book has one publisher, that's the one side. Again, the foreign key is going to go into book. Now I come to author. An author may write one or more, an author may write many books. And a book may be written by many authors. There are many examples where a book has more than one author. Lucifer's Hammer is written by both Parnell and Niven. So this book has two authors to it. So here is a many-to-many relationship. A book has one or more authors. A book has many authors. An author may write one or more, may write many books. And because this is a many-to-many, as we remember, we then need to create a connector entity. This is how a many-to-many works. So we will create the connector entity. We will call that rights, because that's what the relationship is. And then as such, we're going to then turn around and put in the cardinality that's associated with it. And remember, we just switched them out. And now what I have is that an author can write many books. A book can be written by many authors. What I will have is I break this into a new table. There's my primary key. The primary key goes into here as the foreign key. Foreign key for there. The book ID number goes in here also as the foreign key. Looking at there, then what I've got is, again, because remember, the attribute name did not have to be exactly the same. All it has to contain is the concept of what that connection is. So this is a book ID number. What it'll be contained with or populated with is the ISB number of that book. And I'm going to add into there the year written. And since I'm storing that in year written as an attribute of the relationship rights, not the author, not the book itself, but of the relationship, I'm going to turn around and then store that in here. I've now normalized this data. I have now turned around and have created my normalized, and what's going to happen here now, when I actually create this into a database, I will assign, for example, a number. Arthur C. Clarke will be number 2. Simon & Schuster have the ID publishing of 4, and the genre historical romantic novels will be genre ID 6. What happens then is when I create a book and I enter an actual instance in the book, I will have the ISB number that's assigned from the Library of Congress. I will put in the title of the book, regardless of what it is, even though it may be duplicated to somewhere else, because it still will be uniquely identified by that ISBN, just as we could have had students with the same names, and we would have never normalized the student name. That we could still have students with the same name because they will be differentiated by the primary key. I will then put for this book the publisher ID. Well, that was publisher 6, knowing that that's going to be identified with, as I said, historic romantic novels. The publisher's name there will be 4. That's going to be my Simon & Schuster. And then this is going to be written by this author here. So this book with the ISBN, whatever the number is, written by author 2, and that was written in 2020. This is how it's going to be used. Looking at this now, I have now validated this design. Have I created one that is going to, A, will it accomplish the task I want it to? Will I be able to build my app that's going to store all the books that I have? And yes, it validates and accomplishes that. Then B, have I normalized this? Have I removed or at least reduced the possibility of them entering data incorrectly? And I have by normalizing it. By turning around and breaking this down, I now have a database that is going to perform its function and reduce, if not remove, the probability of data duplication. This is what's meant by normalization. So looking at this, now the author ID is used to identify the author. There are no bad entries. The change of name only needs to be in one place. Say I decide later on down the road that what I want to do is I want, instead of Arthur Charles Clarke, I want to have it stored as Arthur C. Clarke. Pre-normalization, I'd have had to go through and find every example of Arthur Clarke, Arthur C. Clarke, Arthur Charles Clarke, and change all of them. With normalization, I simply go into the author table. I will go into there and just change the name to Arthur C. and then last name of Clarke. And now every time I pull up a book written by that author, it will come out as written by Arthur C. Clarke. So here's another benefit, or an extra bonus, if you will, of normalizing a database. You only need to change that once, then is going to make it more efficient, and then that change propagates throughout the entire database. Every book this person has written is now going to be associated with the style of the name I have now entered. So looking at this, these are the reasons and how we normalize. So looking at it, again, how would you normalize a database? You would go and inspect your table, and you would ask yourself, is this data repeated data of a finite nature? In other words, it's not a matter of like, well, it would be repeated once or twice, but there's literally hundreds of different entries that can be put in there. It's, are there only going to be 5 or 10 or 50 entries even? But they're going to always repeat. And they're going to repeat with enough frequency that it's worth the overhead of breaking this down and normalizing it. And a lot of times you're going to see this is going to be very self-evident. You will look and see, yes, this data, I am storing the type of measurement. There's only 6 types that I can think of that are going to get stored there. But if I have 100, 200, 1,000 entries that has these same 6 weight types repeated, there is a high probability of error. This field, therefore, should be normalized. And you just go through your database and you look at every field and you simply ask that question. And again, like with a lot of the material we're covering in this course, this is as much an art form as it is a fact. Trying to teach something like this is something that comes with experience when you know the basis of what you're doing. So this is why the exercise you're going through and you're looking and you're saying at the databases that you're building, are there fields here that need to be normalized? Once you do that, what you're going to then have is a better functioning, more data integral or more data integrity in your database. And that concludes our discussion on normalizing data in a database.